for this Saturday at PyCon 2015. It's great to see so many of you in the audience. And you've joined us for a block of talks that's entirely about testing. And our first talk today is by the Director of Engineering at Magnetic Labs, who's going to be teaching us what is a good test and what is a bad test. Please make welcome Dan Crosta.
Thanks, everyone. I don't want this to sort of be too negative, so I'd like to begin by running through some of what I see as sort of the virtues of a good test. These are the things that we sort of want to aim for as we're writing tests for our code. So first of all, good tests should be fast. It's been my experience that developers won't run tests if they're slow, and then you'll get your builds are broken in your continuous integration suite, or worse, if you don't have that, it could be broken in production. So good tests are fast. Good tests are selective. What I mean by this is that a good test is going to test just one thing at a time. If you have sort of one bug in your code base, you don't want multiple tests to fail. You want just one test to fail, and that'll sort of point you in the right direction of what you need to fix. Good tests are repeatable, so you should get the same result every time. You don't want your tests to be sort of flaky, or dependent on random behavior or time sensitivity, or particularly, we've had a lot of issues at Magnetic with tests around daylight savings time. Every year, inevitably, a whole bunch of tests stop working. We don't like that. And sort of related to repeatability, a good test should be reliable. So your test should always pass if your code is working, and your test should always fail if your code is not working. This is sort of what it means to be a test. And last, but sort of most importantly to me, a good test should be helpful. I couldn't really think of a good sort of single word for this, or single term. But what I really mean here is that your test should tell you what is broken, not just that some generic thing is broken. So how many of you, let's just get sort of a show of hands from the audience, how many of you have gotten a failure from your test that say, assertion error, false is not true? Right, so that's not super helpful as an error message from your test suite. It doesn't tell you what should be true or what currently is false. If that happens, your only choice is to go and read that test and sort of reason through it in your head and figure out what's going on and why it's not working the way that the test says it's supposed to. So the important lesson here is that it's actually more important how your test fails and how it behaves under failure conditions than how it passes. And this is one of the sort of key lessons of test-driven development. The whole sort of red-green refactor idea is that you want to see your test fail and make sure that it fails in the right way before you then fix the code or implement the code in order to make it pass. So I want to warn you all right now, this talk is sort of full of opinions. Opinions aren't rules, so these are things that have sort of worked well for me in my experience, and they may or may not work for you depending on exactly the sort of code that you're writing and the code that you're testing. As always, you should use your judgment when sort of exercising these opinions and applying them to your own code base. So the rest of this talk, the way that we're going to sort of tackle this is I'm going to point out three, what I see at least as common myths about testing, sort of explain why they're bad, why they lead to bad testing practice, and what you can do to avoid making the same sort of mistakes that I and my team have made. So myth number one, 100% coverage. What typically happens here is that you implement coverage.py in your continuous integration suite, and then suddenly your whole team is sort of rushing to get every single line of code tested and make sure that you hit that 100% mark. The theory is that if every line of code is covered, or if every branch is covered, then you know for sure that your code does exactly what you think it does. As you can guess, I sort of don't entirely agree with this statement. So let's take an example. Let's say there's some part of your code that's interacting with a third-party API. In Magnetic's case, this is Amazon S3 a lot of the time. And so, that's part of our code base. We should test it, right? Well, there's a reason that we sort of draw the internet as this cloudy, nebulous sort of thing. We don't really know what's actually going on there. And it turns out that actually anything could happen there. And the things that could happen there sort of don't have any relationship to your code. There are things like maybe it's slow, maybe you're on an airplane, maybe you're connected over a telephone, all sorts of things that could cause your test to break or cause your code to behave differently. That has nothing to do with your code. It has to do with sort of external factors. So tests that test this sort of stuff tend to sort of blow up in extraordinary ways at unexpected times. I call these mutually assured destruction tests, or mutually assured sort of code segments. And the idea is that either everything sort of works correctly, or something is broken in the internet, or something is changed out in the world, and suddenly your test is failing and you sort of don't know why. What? Sorry about that. So my recommendation here, and again, this is sort of one of those opinions, is that there does exist in probably every code base some code that should not be tested. And the way that you can identify what code sort of falls into this category is to ask yourself this question. So what would cause my test to fail? If the answer is ever the internet, then that's probably not a test that you actually want to have in your code base, because it's not going to tell you anything interesting when it fails. Instead, what you should do is sort of keep that plumbing code, the stuff that talks to external services, the stuff that goes out over the internet, keep that code as dumb as possible. And what I mean specifically by dumb is that you shouldn't sort of have any of your business logic tied up with it. You want it to sort of fail very loudly when something unexpected happens. And this might mean things like using assertions in the code. So if you depend on getting a certain type of response from an API, assert that that's what you get. And of course, since this code is sort of running in production and not on our machines or in a sandbox, you need to make sure that your monitoring and exception alerting actually works in production. So that should be something that you test sort of manually as you set it up and make sure that you get those messages. Okay, myth number 2. So assert about everything. So the idea here is that if I have more assertions in my test suite, I have a higher degree of confidence that my code is actually doing what I think it should be doing. So let's take a look at a little example. Let's say that we have a function which parses a log line from a web server or something like that, and it's going to return a dictionary into this parsed object here. So the sort of obvious and naive thing to do is to say, we'll make sure that the thing that it returns is exactly equal to what I know it should return. I'm controlling the input. I can tell you exactly what the output should be, so let's just make sure it's exactly that. So what would happen if this test fails, right? We would get a message that says, these two dictionaries aren't equal. Depending on how long the dictionaries are, it might be sort of impossible to read. So this violates our sort of helpful principle or virtue of helpful tests. So we can sort of trivially refactor it just by asserting about each independent field individually. And at a glance, this looks like a sort of reasonable approach, right? So now if we get, let's say that we parse the date wrong, there's some sort of time zone error, then what we'll get is a message, sort of for that particular line. And if we look at the test, we can see very quickly, okay, there's something wrong with parsing the dates. So that's okay. So let's look at how it might evolve over time. As you add sort of more test cases to your suite, inevitably what happens is that people will sort of copy and paste all these assertions from one to the next. And now if you have a bug in that time parsing function, let's say, then what you're going to have is that all of your test cases are going to start to fail, and you're going to be overwhelmed by failure messages until you can figure out what's actually going on. So this now sort of violates our sensitivity principle, right? Because we're going to have lots of tests that are failing, but actually there's only one bug going on in our code. So the right way to identify this is to ask yourself, what would I do when a test fails? And if the answer is I have to go and read that test and figure out exactly why it failed and where it failed and what that really means for my code, then your tests aren't sort of helping you as much as I think that they could be. And the solution is that we want to have our tests tell us exactly what is wrong. So in nature, we build these sort of very big things like the sand dune here out of very, very small little particles, grains of sand. And we want to do the same sort of thing with our test suite in order to make sure that we get the most value out of it. And so my recommendation is to make literally only one assertion per test case. So here's the same sort of test suite as we were just looking at for this parsing function. but with only one assertion for test case. And what you'll notice is that as you start to write your test this way, your tests actually change. So earlier, I think it was called test it parses log lines. Now, once we've rewritten it to be one per test, one assertion per test, we end up with test it parses the request method, and test it parses the request path, and it parses the query string. So now your tests are actually, just the name of the test itself, when that test fails, will tell you what's actually gone wrong, or at least approximately where you should look to figure out what's gone wrong. I also find that, here for brevity, I had to sort of elide most of the test case, but the tests actually get much more readable as a result of doing this. So you'll see the sort of standard 3-part test. You'll have set up some data that you want to feed in, which is the log line. You'll exercise your code, which is the parse function, and then you'll have the one assertion. And you can just sort of read it top to bottom and see, okay, this is exactly what my test is telling me that the code should do. Okay, myth number 3. So mock makes tests better. And here I'm talking sort of specifically about the mock library for Python. So mock is supposed to sort of help us, among many other things, isolate the layers of our code so that we can test just one layer at a time. This is actually true. Mock is a good tool for doing this. But mock comes with a lot of risk, and it can introduce a lot of danger to your test suite, which I'll hopefully be able to demonstrate now. So let's say we had some sort of web application, and we have a login function which calls an authenticate function. And that authenticate function for now is just returning true or false whether or not the user is sort of allowed to access this system. So if the user is not authenticated, we'll return a response with a 401 error code, which means that the user is not authorized. Otherwise, we'll eventually end up returning a response with code 200. So if we want to use mock to sort of write tests and we don't want to deal with what users exist in the database, or maybe our database is slow, and the tests are too slow, and that's why we're using mocks, just to sort of avoid all of that sluggishness. We might end up with test cases like this. And these are, as they go, they're basically okay. Where am I? So the question that you want to ask about tests like this, or anytime that you're using mock, is why might my test pass when it really should fail? So this is sort of the danger with mock, is that you're not actually calling real code, you're calling a mocked sort of fake version of the code. So your test could keep passing when it really should be failing, and it really should be telling you something about your code anytime the thing that you're mocking changes. To put it sort of glibly, mock sort of quacks like a duck, but it's not actually a duck, right? It's a mock duck, or a chicken, or a goose, or something in this case. Mock quacks basically how you tell it to quack, rather than how it's supposed to quack. So the simple thing to do to sort of fix this problem and to make it much better for your test case is to use a verified double in place of a mock. So what a verified double is, in this case, might look something like this. So you have some sort of DB layer that has a method called authenticate, and that's supposed to return, true or false. Right, so rather than mocking it, what you'll do is you'll just sort of write in a thing that's not actually talking to a real database, but which is sort of imitating the behavior of that database, so that piece of code that you're replacing. And using this, I think that your tests actually end up being much more readable. So here we can see sort of the exact set of steps that leads to the outcome that we're testing. So in the first case, if we've registered a user and then we attempt to log in with that user, then we can see that we get back a 200 response code. In the second case, we haven't registered any user, so the database is effectively empty. And when we attempt to log in, we get back that error code 401. So these things can be a little bit of a pain to write, particularly if the thing that you're trying to double is very big. But we as a community can sort of make this easier for everyone. So let's say you're shipping a library for Memcached or Redis or something like that. what I'd like to sort of call on all the library authors out here to do is to actually ship along with your Python packages in the cheese shop verified doubles that do sort of exactly what the real thing would do, and which let users sort of stub out these databases and libraries that we use in the world in order to make our testing better for everyone else. And I think it's important also to note that when you're doing this, you actually want to ship that with the package in the cheese shop and not just in the source tree, so that everyone can use it and it's not just available for your CI suite. Okay, so we'll wrap it up here. And what talk wouldn't be complete without a picture of kittens, right? So the sort of core thing, the core point that I want to make here to start is that just like your code can smell, your tests can smell too. Tests that are long or complicated or mysterious aren't sort of helping you as much as they could be. And therefore, just like it's important to design your code, it's important to design your tests and think about how you're writing them. And this is the sort of the way to avoid these smells. Trying to write a fake for some other piece of code, let's say it's not sort of part of your application, but it's something that you depend on. What I've actually done in that case is submit that back to the upstream author as a pull request against their repository, so that can become part of that library that gets shared then with everyone else.
Thank you.
Yep.
Okay, so we're going to take 2 questions from this aisle and then you.
Great talk, thank you. You had talked a little bit about some of the challenges with testing third-party services as well as some of the pitfalls of using mock. When your code is having to write custom URLs for things like posting to S3, what's good testing practice? Should you just assume, I assume you shouldn't say your URL is just correct. Can you maybe talk a little bit about how you would test against using a third-party API?
So let me sort of repeat the question to make sure that I understand what you're really asking. I think what you're asking is, if part of your code is constructing a URL or a key for an object in S3 or something like that, based on some criteria that only the code knows, it's not sort of static, how do you test whether you're creating it correctly? Is that what you're asking?
Perfect, thank you.
Yeah, so in that case, I think the right thing to do is to factor that out into a separate function, which is a pure function, right? So it just takes, however many arguments as input and produces a string as the output. And that's then trivially testable as a unit test, and it doesn't have any dependence on the third-party service.
Great, thank you very much.
Sure.
Hello, thank you for your talk. I missed the beginning, so I don't know if you tell which test runner do you use?
Which test runner do I use? So theoretically, they all should work. In practice, I think that some of them work better than others. I've been using trial primarily these days. The reason that I use trial is that we do a lot of testing with the test scenarios framework, which is really cool, and everyone should look it up if you haven't heard of it. Basically, what it lets you do is, it's sometimes called like table testing. So you just define a bunch of sort of inputs and the expected outputs and write one test function that's basically parameterized. Long story short, the reason I use trial is that with the unit test framework, trial is actually going to give you sort of separate lines of output for each of those different test scenarios, and they're sort of named based on the name of the scenario. But at the end of the day, all the test runners basically do the same thing. They have some method of test discovery, and then there's a sort of prescribed way in Python unit tests to go and actually run that test, and hopefully they all do that in roughly the right way.
Okay, my question was, when you talk about copy-paste some test code, it's a common problem, but I think your solution is just a workaround about some unit test limitation. If your test runner could be a little smarter about test dependencies, don't you think that you should be able to have one test that call several other tests and tell you, oh, okay, one of test login doesn't work, so this one doesn't fail also, but it's not its fault, it's the one of test login.
I mean, that's a really interesting idea. I'm not, I don't know if anything that's sort of out there open source already does that, but certainly that would be a really valuable feature to add to, probably to sort of the unit test framework itself rather than to a particular test runner. But yeah, I think that could be really interesting.
Okay, I will be happy to sprint about it if you want.
Yeah.
All right. I had a question. When you're talking about mocks, when does it make more sense to actually use the actual database, or I shouldn't say an actual database, but something like SQLite if you're testing against a database with an actual SQL fixture, one per test, so that you're always testing against a known database and you're actually testing real SQL. Or for example, Redis, using Redis Lite to get multiple Redis instances that each test has its own instance with its own RDB fixture. Mm-hmm. And you're actually not mocking, but you're actually testing against the thing that's actually being used.
Yeah, so I was a little afraid of saying anything about mock in a PyCon talk because I think it's really powerful and it can enable some really fluent testing approaches. I've also seen it sort of misused in a lot of terrible ways. And so I would sort of rather be on the record as saying, don't use it, by which I mean use it with care, rather than use it as much as you can. As far as sort of when we would want to use the real thing rather than using a verified double, which is what I'm recommending here, it might be that it's too hard for some things to actually create a double that's sort of close enough to the real thing. MySQL is probably a really good instance of that because MySQL has probably as many edge cases as any other piece of software out in the world. So if that's sort of important to your test suite, if you're, say, the author of an ORM library, then I think you would want to test against the real thing. If you're just writing an application and you're using an ORM, then it might make sense, depending on sort of the exact situation, to write a double for that ORM, or maybe to use one if it ships with the ORM. That will just make your test suite faster and sort of less subject to the quirks and vagaries of that particular thing that you're testing against.
Well, related to that then, would it make sense to actually develop the stuff so that we could actually use the real thing easily with the test cases instead of using a double or a mock?
I'm not sure I understand the question.
Well, I think Django already does this when it runs test. Mm-hmm. Right, it will spin up SQLite database mm-hmm. instances and actually test with an actual database. A lot of times, something like that can actually be easier to implement from the standpoint of the user doesn't have to have details of how the thing's being mocked out or creating a double from scratch.
Yeah, I mean, SQLite in some ways could be thought of as a test double. Okay. It acts very closely to the sort of grown-up I have a server databases. There's some parts of SQL that it doesn't implement, obviously, right. And hopefully the ORMs, like the Django ORM, sort of hide that detail from you. So in that case, using SQLite is probably fine. Okay. I think it's really a judgment call. What's going to work best for your particular case. We don't at Magnetic. We're not testing a lot of code that works with an ORM and a sort of big relational model. We're doing sort of request response types of things, and we use typically key value databases. So in our case, it's very easy, and it's a little bit of a cheat to say that you should spend your time writing this double because it was really easy for us to do that.
Well, that looks like all the questions that we have. So everybody please thank Dan for a fantastic talk. So next talks will start at 11:30. This is finished a bit early, so go wander around and come back here for then. See you soon.
Thanks.